Properties of rhombuses, rectangles, and squares is what we're going to look at in section 6.4. So let's look at some definitions first. Special parallelograms. So a rhombus is a parallelogram with four congruent sides. So all of the sides are congruent to one another. So that side equals that side equals that side equals that side. Okay, so that's a rhombus. A rectangle is a parallelogram with four right angles. And a square is a parallelogram with four congruent sides and four right angles. So it's a rhombus with right angles. So those are the three special parallelograms that we're going to look at in today's lesson. Okay, so let's do some quick theorems. Theorem 613 says if a parallelogram is a rhombus, meaning if it has four congruent sides, then its diagonals are perpendicular. So if these four sides are congruent, then we can say that these angles are all 90 degrees. So that's theorem 613. And you'll see how we're going to use that in a minute. Theorem 614. Again, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So this bisects this. It also bisects this side. Remember that in a parallelogram, the opposite angles are congruent. So therefore, if I bisect angle B into two pieces, those two pieces will also equal angle D divided into two pieces. And we will bisect the angle here and the angle here. So two things when a parallelogram is a rhombus. The first one we did in theorem 614 was that the diagonals are perpendicular. The second one is that the diagonals bisect the opposite angles. Okay, so here's an example of what we're going to do with this. If we are given a rhombus, ABCD, with these measurements, this angle is 58 degrees, and we're going to call this angle 1, 2, 3, and 4. You should now be able to find all the other missing angles. So pause the video real quick, see if you can do it on your own, and then come back. Okay, angle 1 is 90 degrees by definition of a rhombus, that the bisectors, or excuse me, that the diagonals are perpendicular, so all of these angles in here are going to be 90 degrees. Angle 2 has to be 58 degrees, and that's by alternate interior angles. Since in a rhombus, this side has to be parallel to this side. AB is parallel to DC because it's a parallelogram. Using AC as a transversal, we have alternate interior angles. Angle 3 also has to be 58 degrees because the diagonals of a rhombus bisect, meaning divide this angle into two equal parts. So if angle 2 is 58, angle 3 has to be 58. Then the last thing I can say is that angle 4 is 32 degrees, and that's by the angle sum theorem. Because we know that angle 1 plus angle 3 plus angle 4 have to equal 180 degrees. We know what 1 and 3 are already. 90 plus 58. And if I add those together and subtract, I get 32. So using the theorems that we've used in the past, like alternate interior angles, and using the two new theorems for a rhombus, we can solve a lot of different missing pieces. The last piece of information or theorem that we're going to look at says if a parallelogram is a rectangle, then its diagonals are congruent, meaning that A, B, C, D, AC is congruent to BD. Since we also know that the diagonals of a rectangle have to bisect each other, right? So we know that all four of those have to be equal. That's all we have.